right, so I should be live right now, I believe. I'm just making sure everything's set up. Just let me know if you can hear everything. Can hear everything that we don't need? Okay. Okay, Jaden, thank you. Christina, thank you. Okay, looks like we're good. All right, sorry for that slight delay. I usually have a typical setup where I put this, but I recently moved things around in my house, and so my setup was changed. Anyway, I'm gonna start with the review that I actually posted. So I'm going to go through some problems throughout that. And if you have specific questions, you can post them on the live feed, or you can even email them to me because I'll have my phone right here during this whole entire session. So I'm going to go for about an hour, I think, if I can last that long. So let me just pull this up here. Let's see. Okay, so anything specific that you all want or anybody wants? I'll wait a few minutes, or not really, a few seconds. Let's see. Okay, so make sure you all know that the exam's at night, okay? It's not in the morning, so 8:45 p.m., not a.m. All right. So I don't see any specific requests at this time, so if that's the case, then I'm going to start going through some of the problems right off of the practice. Stuff from quiz 2. Oh, sure. Yeah, we could do stuff like that. Exponent type of things. All right, so let's start with 1B. So just make sure this is positioned okay. All right. So 1B is -2/8 plus 1/4. And then in parentheses, we've got 16 minus 1/2. Okay, so by the order of operations, we want to start with what's in parentheses first. So we have 16 minus 1/2, which if you think about that, that would be 15.5, right? So oops, what am I writing? I have no idea. Okay, -2/8 plus 1/4, and then this is 15.5. Okay, you can change this to an improper fraction. So that would be 31/2. Okay, now it's going to be very tempting to want to add these two fractions together out front, but you cannot because by order of operations, you have to multiply first. And this right here is multiplication. This would be addition. So as much as you might want to add these, don't. You actually have to multiply first. So we would have -2/8 plus, now when you multiply fractions, there's no need to get a common denominator. You can get one, but it's not necessary. So we multiply right across, 1 times 31, and then 4 times 2, which is 8. Okay, now we're adding fractions, and the denominators are the same, which is what you would need when you're adding fractions. So we would leave that denominator as 8 and combine the numerator. So -2 plus 31. Let me just move this a little bit. Okay. -2 plus 31, or you can think of it as 31 minus 2, and that is 29. 29/8. And 29 is a prime number, so we're not going to be able to reduce this anymore. Okay, and by the way, I'm going to be posting an answer key to this whole entire practice tonight, or yeah, I'll do it tonight. Okay, how are we doing so far? Can you use calculators? No calculators for any of the exams, just like we don't use them for the quizzes. Okay. All right, let's see. Let me do Let me point out something like 2a. Let's get this off. All right. Okay, here's something like 2a, okay, like 2a. And when we're distributing, how do we know which piece to distribute? Okay, let's say we have 3x minus 4 times, I don't know, 8x squared minus 4x, okay? There are no parentheses around this expression. So what this is there's a subtraction sign here, and then we have 4 next to this expression, so that would be multiplication. So by order of operations, we would do multiplication first. So you're going to distribute the 4. You can actually do the -4 into this whole entire expression. So -4 times 8x squared, -32x squared, and then a -4 times a -4x is 16x. Okay, so now all the terms are completely out of parentheses, and we would combine like terms. And like terms have to have exactly the same variables with exactly the same degrees. So we've got a 3x and a 16x. Those are the only like terms. So we'll have -32x squared and 19x, and that is it. Okay, so in this example, you're only distributing the 4, okay? There's no other set of parentheses. But if you were to have something like, let's take that 3x minus 4 and put it in parentheses, okay? I need to go get a drink. I'm thirsty already. Okay. This is different, okay, totally different. So now you're multiplying this whole entire expression by this whole entire expression. So as long as you're organized and you're not multiplying the same 2 pieces together more than once, it should be fine. It might turn out to be a lot of terms, but other than that, so usually I'll start with the first term here and I'll multiply into the first, into the second over there. So 3x times 8x squared is 24, and then we add exponents, so 2, and there's a 1 there, an implied 1, so x cubed. What's happening to my marker? X cubed. And then we've got 3 times -4 is -12, x squared. And so now I'm done with this guy. So what I'll do is multiply the -4. -4 times 8x squared is -32x squared. Can we squeeze this? And then -4 times -4x is 16x. Plus 16x. Oh, there we go. All right, now we combine all the like terms. It looks like we only have these guys in the middle that are like terms. So 24x cubed, a -12 and a -32, let's see, that is -44x squared, and then just a 16x. Okay. So you see the difference between distributing only a -4 and then here, both terms. And of course, there could be 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 terms, which don't worry, there won't be 12 or 10 or 9. Okay. All right. Let me take a look at some comments here. Are the quizzes posted on MyMathLab? If you are in the online course, ignore the quiz comments, okay? Because my ground classes are doing quizzes. You guys will be doing quizzes, but after midterm 1. Can I write what the exam is going to ask? Oh, okay, I see what you mean, like the wording. Okay. Sure, Charlene, yes, exponent and fractions. Okay. Let's do You know what? Let's do one more of these, and we'll put some fractions in there. Okay. All right, let's do, and maybe what you can do is, I mean, obviously if you're watching this video later, you can pause it and try to do it on your own, but maybe I'll give you a minute to try to do this. So let us do 1/2 x minus 10x cubed, and we'll multiply that by 4x plus 8x squared. There's only one fraction in there. Should I make it another fraction? Yeah, let's do another fraction. Let's make that 1/4. Okay. All right, so again, we're going to start with this term and multiply in and in. 1/2 times 1/4, no common denominator needed, so multiply right across. 1, and then 2 times 4 is 8, and that would be x squared. All right, 1/2 of 8 is 4. X times x squared is x cubed. And 10 times 1/4, okay, remember you can throw a 10 over a 1. So now you can imagine that's your numerator and denominator. So minus 10/4 x to the 4th. I should point out that I'm doing this right now. Okay, and then -10 times 8 is -80 x to the 5th. All right, great. No common, no like terms at all. The only thing I really want to do is simplify this. 10 over 4 simplifies down to 5/2. And I kind of want to put this in descending power form. Not that you have to, but I want to do 5, 4, 3, and 2, second power. Okay, so either one is fine. Well, actually, you should reduce this, but there we go. Okay, not so pretty to look at, but hey, it's the answer, okay? All right, so now just a few comments about negative exponents. So I've been noticing this pretty much every time I teach this course, and people get really confused about what negative exponents do to numbers. And I spoke about this in the ground course, and I feel like I still need to talk about it again. So let me remind you, okay? Negative exponents do not necessarily make numbers negative. They make them smaller. Now, they could turn out to be smaller negative numbers, but that totally depends on whether the base is negative or not. Okay, so here, let me see if I can clarify some of this. 3 squared, okay, we know is equal to 9. All right. 3 to the -2nd power is not -9, and I keep saying this. It's equal to 1 over 9. So you see how that got smaller. It's not like your typical 9 from a 3 square. It's 1 over 9. It's a fraction. It's not negative at all. Now, if I take -3 in parentheses and square it, I still get a 9. All right. If I take a -3 in parentheses and raise it to the -2nd power, that's going to be equal to 1 over -3 in parentheses raised to the positive 2nd power, which is still 1/9. Okay. So because it's an even degree, it's not changing the sign. It's keeping it positive. Okay, but now let's take -3 and raise it to the third power. Or actually, you know what? Let's do this. Let's not put parentheses around it. Let's do this. If you do not see parentheses around the whole entire expression, you can only assume that the 3 is being squared. So it's almost like you can temporarily cover up the negative sign. 3 squared is 9. And so this is actually -9. Okay? If I do this, -3 to the -2nd power, same deal. Only the 3 is being raised to the -2nd power. So you have a -1/9. Okay, I hope that's clarifying some things. One example that I usually give as far as helping people understand that negative numbers don't necessarily make numbers negative is scientific notation, right? Back in the day, if you did something like 3.1 times 10 to the 5th, you would move that decimal place over 5 times and get some large number. Let's see. 1, 2, 3, 4, 5. Is that right? 1, 2, 3, 4. Yeah. Okay. Right? But if I was to raise this to the -5th power, I would move the decimal over 5 places to the left. So that makes it significantly smaller. So let's see, 1, 2, 3, 4, 5. Yeah. Okay. A lot smaller number, not necessarily negative. Now, again, it could be negative, but that would mean that the base would have to be negative. Okay, kind of like it was over here. Okay, hopefully that clarified a few things. I don't know. Let's see. All right, everyone doing okay so far? Okay. So let's see. Let's look at, well, I think 3, they're all pretty straightforward. Let's take a look at 4B. I need to move a little quicker here. We've got 3 to the -2nd minus 2 to the -3rd. All right. In 1 minute, I need to go get something to drink because I'm parched. But all right. This, okay, is going to be 1/3 squared minus this is going to be 1/2 cubed. 3 squared is 9, and 2 cubed is 8. So now you need to get common denominators and subtract these two fractions. Okay? Now, 9 and 8 really have nothing in common as far as a common factor. But if you multiply the two of them together, you get 72, and 72 is a multiple. So we can multiply this by 9 on either side and 8 on either side. So we have 8 times 1 is 8 and 72, and then 9/72. Okay. So again, common denominator, we leave that down here. 8 minus 9 is -1, and that's our answer. Okay. All right. So as I go get my drink, and don't worry, it's just juice, okay? 7A is what I'm going to do next. As I'm doing this again, if you have any questions on specific problems that you want me to look at, then just type them in the live feed box or email me. All right. All right, yeah, back. Okay. All right, so for those of you in the ground class, we haven't quite gotten to this yet, but we will on Tuesday, don't worry. So here is basically two fractions. We need to get common denominators. And just because there's an x in this one and an x in that one, doesn't mean that all we have to do is subtract one from this side or something like that. So think about this as being one number and that's a totally different number, right? Like if that was 5, this would be 5 minus 1, which is 4. So you can basically multiply the two of them together to get the common denominator. So what I'm going to do is multiply this side by that piece. And then I'm going to multiply this side by that piece. So I need to get my other marker. This is awful. Minus, okay, and x and x. Where did I put it though? That's the problem. Okay. So now be very careful when you're multiplying this expression by this expression, okay? Even though there are no parentheses there, it's implied that the whole entire expression is being multiplied by this expression because that's the numerator. And we're multiplying the whole numerator by this piece, okay? Which is very different than what I was pointing out before with just that -4 being distributed. So here we're going to have x squared and then minus x, then another minus x, and then plus 1, okay? Over here we have an x squared, and then our common denominator is x times x minus 1. All right, we can cancel all like terms, so this cancels with that. We have -x minus x is -2x plus 1. And we can just distribute this to simplify. X squared minus x. And we're done. Okay, I know there's a lot of x's hanging around, but you cannot cancel any of those. You can't cancel this one with this one, or this with one of these, because this x is part of the numerator, separated by an addition sign. Okay, so when there's addition or subtraction, you can't go canceling terms. If there's multiplication, then you can. Okay. Let's take a look at 7b, actually. Okay. And yes, I saw your question, Charlene. We'll do some from 4. And then Brittany, yes, 16 and 17. Sure. Okay, so for 7b, let's see. We've got x squared plus 2x. And then, is that coming up okay? I really need to go get my other marker. 2x plus 4. I'm a disaster today. Okay. X cubed plus 2x squared all over 2. All right, so Essentially, what we have here is two fractions. And when you're dividing fractions, we use that reciprocal method, keep, change, flip. So we would leave this fraction as it is, we would change that to multiplication, and then flip this to be the reciprocal. So I'm going to do that right now. Okay. Actually, let's change that to a dot. Okay, so now comes the fun part. We want to find all the factors that can be canceled. So I'm going to try to factor as many of these pieces as I possibly can. This, I think I see this as being greatest common factor. So I'm going to factor out an x. And I'll be left with x plus 2. This I can factor out a 2. And I'll be left again with x plus 2. 2 is just going to stay. Out of this, again, I can factor out by greatest common factor an x squared. And I'll have x plus 2. All right, so now we can cancel all the like expressions. Or actually not even like, they're exactly the same. So 2 is going to go with 2. That's gone. X plus 2, x plus 2. X with one of the x's. I'll still have an x left. So what we have left over is a 1 in the numerator, because when you cancel things out, it doesn't just turn out to be 0. It turns out to be 1. Okay, so even though everything is crossed out in the numerator, there's still a 1 there. And then we have x times x plus 2. So we'll just multiply that out. And we have this. 1 over x squared plus 2x. Okay. I'm going to go back and do 4C. Okay. -3 to the -3rd power times -2 to the -2nd power. Let me just see if I can grab another marker. Ugh. All right, let's try this. All right, so this is raised to the -3rd power. So we're going to turn it into a fraction. 1 over -3 is still in parentheses, but now to the positive 3rd power. We're going to write this as 1 over -2 to the positive 2nd power. -3, when you cube it, so it's -3 times -3 times -3, is 1 over -27. This is not any better. And this, when you square it, is 1/4. Multiplying fractions together, we get 1 over, and what is that? Let's see, 108. -108. All right. All right. Let's see. Let's do 9C. 9C? No, let's do 9B, actually. Okay, so in parentheses, we've got negative 3x y cubed cubed all over x squared y all squared. Okay, so you can do this quite a few different ways. I always, I'm saying that there isn't just one way to approach these problems. So you might start it one way, and the person next to you could start another way, and the person around you could start another way, and so lots of different ways to do these problems. So don't get stuck in the idea that it's only one way. But there are multiple correct ways. There are also incorrect ways, right? So I think what I would probably do here is probably just get rid of the powers. So I'm going to apply that power to every single base. Negative 3 is going to get cubed. X will get cubed. And then y cubed will get cubed, which makes it a 9. You multiply those powers. Then x squared gets squared, we multiply. And then there's a power of 1 here. When you don't see anything, it's a 1. So that's y squared. All right, this is a negative number. Just because it's a negative number, it doesn't move position. It stays there, okay? Negative 3 cubed is negative 27. And now we can use the quotient rule on these and on these. So with the with the x's, we get 3 minus 4. And with the y's, we get 9 minus 2. And then if you change this to positive exponents, you get negative 27 y to the 7 all over x. And that would be your final answer. 7C, Yana, yeah, okay, let me write these down. 7C. And then multiplying fractions with rational expressions. Okay. Rational expressions in the numerator and denominator, and then also raised exponents. Okay, I think that was this. All one.